Hi, Dr. Anthony Revis here with Watch Me Do It. I'm going to work through some concentration and dilution problems, and I'm going to let you watch me do it. So here's the problem. How many grams of potassium dichromate are needed? That's what this is, K2CR2O7, are needed to prepare 250 mils of a 2.16 molar solution. Keep in mind that's a molarity. Molar means molarity, which means moles per liter. So I need to get the grams from this information. So now when I think of a molar solution, I need to have my moles and I need to have my volume in liters. You prepare 250 mils. So I see my volume because I can convert liters to milliliters, or in this case, I can convert milliliters to liters. And so I just need to get the moles first. So let's get the moles from this first. So to get the moles, then let's just take a look at how we might get these moles. So what am I given? Well, I'm given 250 mils. Now, why didn't I start with molar? Because molar is mole per liter. I do my best not to start with a ratio as my primary given. If you start with a given that is not a ratio, you have a better chance of getting to your results without having to start over and flip your ratios. Okay, so I start with this mill because the mill's not a ratio. This is a ratio. So I'm going to start with 250 mils, but guess what? I need this in liters. So I'm going to convert this, and you can do this a couple of ways. I'm going to do it all in one, then I may come back and do it another way. So this, I need to convert these mils to liters. And so to do that, that's 1,000 mils per every 1 liter. And that, I'm just going to stop it right here and say this is 0.250 liters. And then I'm going to start over. I'm just doing it this way. You could continue in one long dimensional analysis, but I'm going to start over for your benefit. Okay, so now my given is really this number of liters. Now I can go liters and go to moles. And I could have done this in one long dimensional analysis. It's absolutely fine. And so mole per liter is a concentration, molar concentration. So I have 2.16 moles per every 1 liter of this solution. Since it's only potassium dichromate, I'm leaving off the names here because it's only one thing I'm working with. And so when I punch that through the calculator here, I have to go back and remember that I have this really should be only, should be only be 2 sig figs. Let's take that 0 off of there. So this is only 2 sig figs. So don't forget sig figs. All right. So if we do this through, what we get for this is we'll get 0.54 moles of the potassium dichromate. Don't forget those sig figs. Almost blew that one. If you do the same thing I do, catch it, erase it, and move on. So we get that number of moles. Now I can determine grams. So again, so now I have moles as my given. So 4 mole times mole to gram. And I'm not writing this because there's only one thing. If I go through and I look up or I calculate the molar mass, that's going to be 294.20 gram per every 1 mole. And how did I get the molar mass? Molar mass, you may already know how to do this. This is 2K times its periodic table value, 2 chromium times its periodic table, and 7 oxygen. And when we do all that math, we get 294.20 gram per mole. So when I punch this through here, yep, I get 159 grams. I'm having a bad day. 159 grams of this, but I only should have 2 sig figs. Therefore, my final report value is 160 grams. That's how I do it for that. Okay, let's do another one here. How many milliliters of a stock solution are needed to prepare 500 mils of a 1.75 molar solution here? So in this particular case, we have a problem here where we want to make sure we get all the units and everything in the same thing. So here we have how many milliliters we're looking for, and we have milliliters. That's good. So this is a classical dilution problem. We have a dilution. What you have is C1V1 equals C2V2 always. Or if it's molarity, you can call it M. It doesn't matter. It's whatever the concentration is. Okay, whatever that concentration is doesn't matter. So we're going to simply set up this in the equation and let the calculator do its thing, right? So let's see what we have. We have how many milliliters. So that's going to be our C2. Oops, not C2, going to be our V2. I am not doing well. V2. And this is to prepare, this is V2. And this is V1. We got it now. Okay, as long as you make the consistent assignment, you're going to be okay. So this is V1, this is V2, and mils of needed to prepare 500 mils of this. This is your C2 starting with, that's good. There. So let's put these in. We have all the variables identified there. So we have V1, we have concentration of 1. Okay, 1. So C1 is 8 points. You get one, and you just watch me work it. You see all my common mistakes. These are actually common mistakes made a lot too. So here, just watch it through, label everything up properly, and you'll be okay. Where's C2? 1.75 molar times V2, 500 mils. And since these will cancel out, units will cancel out, we're fine with putting in the mils. Since we're looking for mils, we don't need to convert because we're looking for mils. If you punch this through on your calculator, once you put all this in, you'll find that V1 will equal 102 102 mils is what you get. And if we do this properly, what we find is if we have 500 mils and that's 1, then this should be squaring in at V1 equals 100 mil. Okay, that's how we calculate it. I should warn you, however, when people are doing dilutions, they just like to take whatever number rolls out of the calculator. Okay, but properly written, it would be 100 mils to 1 sig fig. Since over here we only have 1 sig fig. Okay, all right. That's it. You watch me do it. I think I'm just redo this whole one.